I was fresh out of undergraduate college with a chemistry degree and decided to dedicate my life to teaching my favorite subject to other people. I made the long move from New York to California and began my teaching career at St. Bonaventure High School in August of 2008. I have been happily teaching chemistry and physical science for 4 years. At the end of my second year, I decided that both my students and I could benefit from the higher degree in education. I wanted to make my lessons more engaging and learn how to incorporate technology into the classroom. I chose to attend Azusa Pacific University because of the Christian environment, small class size, and wonderful reputation for teacher education. Their cutting-edge digital teaching and learning program sounded like the perfect way to set myself apart from other teachers. In this program, I have learned how to create videos in iMovie, create a classroom wiki page, teach students with multiple intelligences, and learn about flipping the classroom. I have already had the opportunity to implement these technology strategies in my classroom and look forward to expanding my knowledge and experience. Being in graduate school has also reignited my passion for learning. I have taken part in several summer teacher programs and have presented my research at a number of conferences. I am thrilled to be graduating with my master's degree in digital teaching and learning and look forward to the many opportunities it brings me as a teacher. My action research was on a personal goal to eat healthier and exercise more. During this study, I was going through my first pregnancy, and as a vegetarian, I wanted to ensure that I was getting the proper nutrition for my growing baby. I also wanted to stay physically active, even if I fell victim to the first trimester sleepiness. In 1 week of baseline data, I found I consumed too many sweets, too little protein, and just enough fruits and vegetables. I only worked out 3 times in 1 week for 20 minutes each. I lacked energy and wanted to make a change. I began to record the food I ate, exercise patterns, and kept a personal journal to note my feelings. I also joined a prenatal yoga class, which serves as a wonderful source of physical activity and is a great stress reliever. I found that by writing down what I ate and when I exercised, I felt much more motivated and felt accomplished afterwards. I made a conscious effort to eat more protein, such as fish, quinoa, and soy, and cut back on the sweets. Very difficult for a sweet tooth like me. After 2 weeks, my collected data shaped up to look a lot healthier than when I began. Graphs and camera aside, now the true challenge is to continue to eat healthy and stay active after the study is over. My portfolio is on the chemical thermodynamics unit. In other words, heat and temperature. This particular topic has many practical applications for students and allows them to connect to the material on a personal level. When I teach any topic, I always try to make connections from the classroom to the outside world. After all, my teaching motto is, "Science is but an image of the truth." The main ideas in this unit include concepts such as, what's the difference between heat and temperature? Why does a hot cup of coffee actually feel hot when we touch it? Or why does an ice cube feel cold? The answer involves discussing the movement of heat energy from warmer to cooler objects. Additionally, we discuss things like, why does sand on the beach heat up so fast in the sun and cool down at night? Why is a metal spoon always hotter to hold than a wooden or plastic one? Next, we discuss exothermic and endothermic processes. Reactions that are exothermic release energy, such as in a hot pack. Reactions that are endothermic absorb energy, such as in an ice pack or boiling a pot of water. The last half of the unit involves the thermodynamics equation, Q equals mc delta T. The equation allows us to calculate the amount of heat absorbed or released during a reaction.
MC delta T, MC delta T, that's calorimetry, yo.
Last, students connect heat and energy to the calories in food. After all, the purpose of eating is to provide humans with energy. Students get the chance to build their own calorimeter, a device which measures the number of calories in a food item. The project takes on a Mythbusters approach in which students bust or verify the myth that baked foods are really healthier than fried. Students start off by watching a brain pop video about the difference between heat and temperature. It provides them with a fun way to understand the important vocabulary. Then they take a quick 10-question quiz on the video. With a partner, students decide whether heat or temperature applies to different scenarios, such as hamburgers cooking on a grill or running a fever. This exercise helps reinforce the concepts that will guide students through the rest of the unit. To introduce exothermic and endothermic reactions, the teacher makes a homemade hot and cold pack. Students witness heat being absorbed to produce a cold pack and heat being released to produce a heat pack. Students read an article from the magazine Chem Matters about hot and cold packs. Students gain some insight into how these packs actually work and then answer some questions afterwards. After learning the Q equals MC delta T equation, students explore the design of a calorimeter, a device that burns a sample of food and measures the number of calories of heat it releases. Lab groups test this out by burning a peanut and calculating the number of calories it contains. They can then compare their answers to the nutritional label to see how accurate the results are. In a final project, the Mythbusters duo Adam and Jamie have asked students to help verify or bust the myth that baked snack foods are healthier than fried. On a team, students must create their own calorimeter from a list of supplies and choose a snack food to test out. Students post all of their lab data and calorie results to the Classroom Wiki site, as well as prepare a summary report of their findings. Other students will post comments and suggestions for the team on how to improve their design and/or results. In the end, this type of creative and collaborative environment will greatly expand students' comprehension of the thermodynamics unit.